The graph of logarithms depends on one significant law. Having understood the exponential graphs, a mix of a truth and some assumptions. So having understood the exponential graphs, we should then understand one law before we move to logarithm graphs. And the law is exponential functions are inverse function of logarithms. I.e. log a y is equal to x implies, and the other way also implies, y is equal to a to the power x. Very, very, very important. You can forget all other things, but not this one under logarithms. This is a law. It is not a rule, which is debatable. It is a law.
Mr. Cake,
Hello.
how are you?
Very fine. How are you?
I'm fine. So is this the first subtopic under logarithms?
Yes.
All right.
In fact, to the nature of this law, I'll give it its own page. Examples will be here.
Sir, can you please bring back the dashboard? I'd like to take a screenshot.
I'll bring back the law. This is the law. Please don't forget this. You can forget other things, but not this one. If you have to enjoy logarithms. Okay, screenshot. Okay.
All right, thank you, sir.
Example sketch. On the same graph, sketch 1, y is equal to log 2x 2. Y is equal to negative log 3. Y is equal to log 2 negative x. And 4, y is equal to negative log 2 negative x. There are 4 functions that are going to sketch on the same graph. Applying this law, we'll move from logs to exponential because we have an understanding of exponential graphs. So say this is x is equal to 2 to the power y. This is the same as x. For this one, first divide by -1 so that you have x is equal to 2 to the power -1. And then on the third one, we'll have x is equal to 2 to the power y, implying that is equal to -2 to the power y. And the fourth, you divide by negative, you have negative x is equal to 2 to the power -y, and then divide by negative, we get x is equal to -2 to the power -y. So we have 4 functions to be sketched. This one to represent the log, this one to represent the log, this one to represent the log, and this one to represent the log. This for that, okay? For this one, for that, for this one. We'll do the sketch.
Sir.
Hello.
Sir, what you've done to the x's is in the law. Is in the law.
Not to the x's, to these questions.
I missed the part when you were talking about it.
So here's the law on screen. Are you seeing it? this. So the base raised to the power x is equal to what? Y is equal to the base raised to the power x. So if I had log z to the base p is equal to 7, this would mean that z is equal to p to the power 7. This is what the law is telling us. If we had log 2, 1 is equal to 0, the law is saying 2 to the power 0 is equal to 1. It's very, very true. That is how the law operates. It can never lie. So this page is specific for the law, not the explanation of the law. Then we move now. We use same table to sketch. We'll be looking for, so the values of y, we use -2, 0, and +2 to sketch 2 to the power y. This is x. To sketch 2 to the power y. To sketch -2 to the power y. To sketch -2 to the power -y on the same. This is what I'm going to do.
So last time we were talking about isn't it the same thing we did last time?
That was exponential, where the variable was y. I mean, the variable was x, y was the function. Today the function is x, y is a variable. Isn't that?
Oh yes, they were like e to the power x.
So we have the sketches here. I don't want you to get confused, because it's very, very hard to avoid the confusion. So we have 2, 0, and -2. These are the y values. We want to look for the x values. When y is -2, this guy is going to be 2 to the power -2, which is 1/4. Yes, we just pick the y values randomly. As long as you have -, 0, and positive, it's all right. So when y is 0, 2 to the power 0 is 1. When y is 2, 2 to the power 2 is 4. So far, we have points -2, 1/4. Point here. -2 means 0,1, 0,1, a point there, and 2,4, 4 here, a point there, and then we sketch this guy. So this is a function of this nature. So we are saying that the y-axis is the asymptote in this case, because we can never get 0 for any value of y. So we can even denote here that we can never touch this line for this graph. For any value of y, x can never be 0. We move. When y is -2, we'll have 2 to the power -2, giving us 2 to the power 2, which is 4. When y is 0, we'll get this, which is 1.
So wait.
Sir, we ask if you can wait, because Apaisemas will be following you behind and will not be able to follow. You are too fast and we are behind in copying and understanding.
The best is you understand and copy it. Since I'm going to give you the video, you cut from the video. Okay. Okay, you can copy, and then the behind.
Thank you.
Sir,
Hello.
you said x would be the asymptote.
The y-axis is the
Oh,
asymptote. The one
okay.
in red.
Why again? Why?
Because x, for any value of y, x can never be 0. And x is only 0 on the y-axis.
Oh, okay.
Last time we were finding the values of x, of y. Now we're finding the values of x, right?
Now I find the values of x. And last time we said for the values of y could never be 0. So the x-axis was the asymptote.
So now what we're doing the reverse of exponentials, the ones that we had.
Exactly, the inverses of those.
All right, thank you, sir.
So you can see that there's always a reflection. For all these graphs, there will be a reflection along the line x is equal to y, or y is equal to x. Okay, so we finish up the second line. When y is 2, we'll have 2 to the power negative 2, which is 1/4. So we plot the points. So we have -2, 4. We have 0, 1, and we have 2, 1/4. So I'm coding from the y-axis. So this is the thing.
Sir,
Hello.
on the last one, is it not supposed to be 2 to the power 2?
The power is negative.
Okay, I've seen. Oh, okay, I've seen.
Okay. We move. We come to the third line. When y is -2, we have -2 to the power -2, which is -1/4. And when y is 0, we have -2 to the power 0, which is -1. When y is 2, we have -2 to the power 2, which is -4. So we have -1/4, we have -1, and we have -4. So -2, -1/4. The point here, 0, -1. The point there, 2, -4. The point there. And then we sketch. So this is going to be of this nature. Leaning on the same asymptote. So I'm going to label these graphs when we are done. So we have another one the fourth line, when y is -2, we'll have -2, -2, giving us -4. When y is 0, we have -2, -0, giving us -1. And when y is 2, we have -2, -2, giving us 1/4 negative. So 2, 1/4, 0, -1, -2, -4. And then we have a sketch. So it's going to be of this nature. Like that. Label. So we have this one from the third line. So this is y is equal to log 2 -x. From the fourth line, this is y is equal to -log 2 -x. And from the second line, this is y is equal to -log 2x. In the first line, y is equal to log 2x. Now this should not surprise us because we had curves of this form the other day, and we saw that we're interested in the family. So these are 4 families of curves. And what will be happening is that when you see a question, whether with a shift or not, your first thing is to check the family where that belongs, and then use the properties like we use them in the first set, because we are still dealing with exponentials after all. Okay, so we can make a statement that this graph here would still be this graph, even if this function was y is equal to ln -x. Even if this function was y is equal to ln -x, still be the same, even if it was y is equal to -ln x. Even if it was y is equal to ln x, we'll just erase the numbers 2, -2, and leave the ones which are 1, the asymptote, and the intercept. When we say ln, we mean, so this one, I can take it to the first page where we have a set of laws. So we'll call this law number 1. We'll call this law number 1. Law number 2, I'm choosing another one. Log e y is the same as ln y. Using the third one, there are so many of them. log 10x is the same as log x. So we have 3.
Sir,
Hello.
excuse me, sir. Sir, I didn't understand what you said about the in.
The in is just log e.
You are saying that it's the same as what the thing. Like you compared it to that graph, sir, the second board.
Okay. So we are saying would have done the same work without specifically indicating -2 and 2 if we were asked to sketch y is equal to ln x. We'll still draw the curve that looks like y is equal to log 2x. In other words, these are families of curves that represents all the log graphs. These are the shapes. This is how logs will be looking like. That is the point.
Oh, so oh, thank you, sir.
Now let's move to another set of examples. In the next 10 minutes, still have minutes, 9, we'll finish one. Example 5, we are still sketching. Now sketch f of x is equal to 2 plus.
Where?
Hello.
I can't ask me if you can take us to the rule number 2 and 3. The other one from right.
I just wanted to see them. Okay, I move you back now. So want to sketch this guy. F of x is equal to 2 plus ln x. This is the same as if we let y be equal to f of x. This is the same as y is equal to 2 plus ln x. So to sketch this guy, it will be like we are sketching y minus 2 is equal to log e x, which is the same as x is equal to e to the power x minus 2. So e to the power y minus 2, not x. It will be the same as we are sketching this thing. Now we already know that the family of this, the family of e to the power y is the first curve here, the one in blue, which is y is equal to ln x. That is the family. Okay, but what is happening is, so we already know the family. So we just look for the intercept. So in this case, the asymptote remains the same. The asymptote remains this guy to never be touched. And then we just look for the y-intercept, I mean for the x-intercept. So Catherine, Never forget page 1. Are you seeing law number 2? No one is going to ask you to write log E as ln. No. It will just appear in questions. It's you to know that here they're talking about log E when you see ln. Or when you see log X, know that they're talking about log base 10. So now we look for the where will the graph touch the x-axis? So we are saying when y is equal to at which point? So if you noticed in the graphs that we had here, we are crossing at 1. But this time around, if you try when y is 0, when y is 0, we'll have x is equal to 2 to the power negative 2, giving us, is equal to e to the power negative 2, is equal to e to the power negative 2 when y is 0. So y is 0 on the x-axis. So now we are getting 1 over e squared. So we are saying we'll cross this asymptote at 1 over e squared. We'll cross the x-axis when y is 0. So what follows will be the graph. Once I know the intercept, I can sketch. So all we need is knowing the family. And then once you get the intercept, you have your sketch. We can as well choose to show, how 1, which was the previous intercept, has moved from being the intercept. It will happen when y is 2, so we'll have e 2 minus 2, giving us e0, which is 1. So at 2, that is when we get 1. If it was important, that's when you get 1. If it was important, somewhere here. But for this graph, what is important is the intercept and the shape. That's all. So
I don't understand. I don't understand, sir.
So to help you understand, you must first understand page 2. These curves are representing the families of curves that are going to have under logarithms. For all the logs that we'll sketch in this course, they will look like this in terms of shapes. So any question you are given, you first get back to this and see which shape you're going to use. After you have known the shape, in this case, our example was sketch 2 plus ln x. The question is, which shape is ln x? The shape for ln x we said is what? Is for question 1, log 2x, where the base is not 2 but e. So log e x. So that will be the shape, not the graph, not the sketch. So after having this shape, it has a shift 2. The question is, how do we apply this shift? So if we introduce to where there's f of x, we bring in y, it will look like this. Then we take to the other side, so that this function is taken to exponentials. So we'll have y minus 2 representing log ex, since we said ln is the same as log e. And then we raise using the first law. So we'll have e to the power y minus 2 is equal to x. So once we have this, we already know the family. So we are doing all this so that we could know, the x-intercept. The asymptote is not affected. The only thing affected was the x-intercept. So once you get the x-intercept, then you sketch the shape that you managed to identify using the family of curves. End of business. So this was just the first example on shifts. So due to the nature of the Zoom,
Sir, so like in this case, 2 is not representing like as a vertical asymptote. We don't treat it like that.
not that too.
Okay.
So don't worry, it's on that this Zoom is limited. So let's log out and get back. We'll do more examples that will help us understand this thing even better.